Right, it takes a few minutes for all the attendees to stream in.
Sure.
And then I'll start the announcement. All right, so I'd like to welcome you to the second lecture of the annual lecture series. Before introducing today's speaker, I will make a few announcements. The first one is that next week we have 3 events scheduled at the center online. The first one is at 1:30 on Monday in the Cognitive Ontology seminar. Mike Anderson is going to be giving a keynote lecture, so 1:30 on Monday. And on Tuesday and Friday next week, Mac Pedroso and Diane O'Leary, who are Q Center Fellows this semester, will be giving a lunchtime talk, so Tuesday at noon and Friday at noon. For these 3 events, you can register for each of them and get a Zoom link on the website of the center. The next ALS lecture is going to be given by Matt Haber on Friday, the 23rd, October 23rd. And today we're going to be using a Zoom webinar. You might be more used to Zoom meetings. So Zoom webinars, the 3 of us right now are panelists and you are an attendee. During the Q&A, I will move those of you who have a question from the status of attendee to the status of panelist so that you can ask your question directly to our speaker today. If you have a question, please go to the bottom of your screen and click on the Q&A function, on the Q&A button, and just write your name. And then I will move you to the status of panelists during the Q&A. All right, so today it's my great pleasure to introduce Stephanie Ruphy, who was supposed to come to Pittsburgh last spring, but because of COVID wasn't able to do that. And we are hoping to bring her again this year to Pittsburgh directly, but we've been unable to do that. So we had to concede defeat and have her give her lecture online today. So it's a wonderful pleasure to have Stephanie, or Professor Ruphy, and I should say Dr. because Stephanie Ruphy has a double PhD. She has a PhD in astrophysics from France and also a PhD in philosophy from Columbia University. She works on a range of topics in the general philosophy of science as well as in the philosophy of physics. She works on scientific pluralism, the metaphysics of science, natural kinds, on models and simulation, science and values, science and policy, and we'll hear about that topic a bit today. But also she's done quite a bit of work in the philosophy of physics. She's a professor of philosophy of science at the École Normale Supérieure, and she has won many prizes, awards, and honors. She was the president of the French Philosophy of Science Society for a couple of years, and she's a member of various academia in France and Europe and the world. And she's the author, last but not least, of Scientific Pluralism Reconsidered, a new approach to the disunity of science, published in 2016 with University of Pittsburgh Press, as well as many, many articles in the, of course, best journals in philosophy and philosophy of science. And today, Stephanie is going to be talking about science policies and the unpredictability of scientific inquiry. The screen is yours.
Okay, thank you very much, Edouard, for the invitation. It's a great pleasure to be able to give this talk, even online. Okay, so let me start with very common assertions on the unpredictability of scientific inquiry. And here you have 2 thinkers occupying opposite ends of the spectrum of political views on research planning. So first, on the planning communist side, you have the physicist John Burnham, who claims that, as so many people, that science is a discovery of the unknown, is it in its very essence unforeseeable, and the plan for its advance might seem, and has seemed to many, a contradiction in terms. And on the other side, on the other hand of the political spectrum, you have the very same view by someone, for instance, like Michael Polanyi. You know, science can advance only by unpredictable steps, pursuing problems of its own. And the practical benefits of these advances will be incidental and hence doubly unpredictable. So on the one hand, unpredictability is at the core of the cultural image of science, and it's very commonly valued as a hallmark of pioneering and creative research. And not surprisingly, many successful scientists, like Nobel Prize winner, just make a case for that. And this is just a quotation by the French Physics Nobel Prize Albert Fer in 2007. I didn't start my research thinking that I will increase the storage capacity of hard drives. The final landscape is never visible from the starting point. But on the other hand, you have this increasing strong demand of accountability and social responsibility. So take, for instance, this recent editorial of Nature in 2017, entitled Beyond the Science Bubble. This ad points to a gap between what science actually delivers and society needs. So it writes that the needs of millions of people are not well enough served by the agenda and interests that drive much of modern science, and researcher leaders in the United States and elsewhere should address the needs and employment prospects of taxpayers who have seen little benefits from scientific advances. So this piece of Nature is an example among many example of expression of a growing dissatisfaction with scientific research and innovation. Global contribution to economic growth is still, of course, on the agenda, but it should not exhaust today society's expectations. You need broader expectations of relevant and, as we say, desirable research and innovation outputs. And this broader expectation motivates, for instance, this central notion of responsible research and innovation in the European Commission research policy. And with this notion of responsible research and innovation, which was central to the H2121 research planning of science, the idea is really to try to, at the end, to better align both the process of scientific research and its outcomes with the values, needs, and expectations of society. Okay, so this is all very nice, but of course there is this prima facie tension between unpredictability and accountability, this kind of social responsibility we've just talked. And so to put it very briefly, this is the idea that the question is, how can you expect science to be socially responsible to deliver what society needs when you cannot predict what science will deliver? And also, even if you could predict the outputs of scientific inquiry, you may not be able to anticipate the acceptance by society. And on top of that, moreover, you cannot always predict what society needs to know. And sometimes urgently, this is obviously the case in the COVID crisis, but in many other cases, you know, when a country faces terrorist attacks, then suddenly you need to know much more about radicalization, for instance. Okay, so my main aim in this talk is to investigate some dimension of this prima facie tension between unpredictability and social responsibility, and to try to identify what I call sticking points or issues to be solved and their consequences as regards policies of research, oversight, and funding. And the outline will be the following. First, I will start with background remarks on the evolution of expectations towards science, and I will explain why I think it's important to start with that before talking about unpredictability and science policy. In the second part of my talk, I will discuss the value of one kind of unpredictability, which is as I will explain, unpredictability as unforeseen applications. And I will suggest that one possible way out of this tension between unpredictability and social responsibility is just to give up or to downplay the value put on this kind of unpredictability. Then on the third part of my talk, I will address the very common view that societal relevance of the research agenda is in tension with epistemic fecundity. And so I will discuss, from an epistemological point of view, I will discuss the soundness of the so-called unpredictability argument in favor of research freedom and very common ground to resist the setting of research agenda. And I will conclude with very brief remarks on pending issues. Okay, so let me start with the oh, sorry. Okay, let me start with this, which could be a first very easy way out of the tension between unpredictability and social responsibility, which would be just to reject any utilitarian, broadly construed, any utilitarian and contextualized views of the aims of science. And it's just the idea that social relevance is just not a legitimate demand on science, contra today very widespread institutional science policy discourses, and also contra many philosophical views about the aims of science, like Kitcher's, Kouranis, others, and so many others. And so this position, this resistance to social relevance is still endorsed today by many practicing and influential scientists. Just to give an example among many others, this is a statement by a well-known British chemist and also 41 members of the Royal Society a few years ago. And the statement is the following: the nature of all politics and politicians means that it's easier for our paymaster to feel comfortable about the proclaiming of programs relating to energy, health, materials, climate change, the hydrogen economy, and so on, rather than to announce, let alone trumpet, that money is available for scientists to follow their curiosity in their own disciplines. And this resistance is really not something new. And if you go back to 1955, you find some Richard Feynman in this nice paper, The Value of Science, stating very similar things, but on slightly different grounds. When Feynman was asked about what makes the value of science, so it seems to be, so just he answers that it seems to be generally believed that if scientists would only look at these very difficult social problems and not spend so much time fooling with less vital scientific ones, great success would come of it. It seems to me that we do think about these problems from time to time, but we don't put full-time effort on them. The reason being that we know we don't have any magic formula for solving problems, that social problems are very much harder than scientific ones, and that we usually don't get anywhere when we do think about them. So I will come back to that later, but just to sum up for the moment, you can escape the tension by claiming that usefulness to society is just not a legitimate demand on science. And why? Because you can say, okay, scientists should be left free to follow their curiosity, because after all, this is when you sign up for a research career, you usually sign up for that, to be free to follow you, or that's what you want to do, to be able to follow your curiosity. And it's, in other words, it's a central ingredient of the cultural image of the job and of research professional culture. And when you start an academic career, that's what you have in mind in most cases. And when you hire a PhD student, you don't evaluate her taste for social relevance. Usually you just want a good creative physicist or a good creative chemist or philosopher. And the second reason, we saw that with Feynman, the second reason is that, well, we can say that scientists are just not good at solving social problems. And here it's in the vein of well-known Kuhn's defense of the social irrelevance of research programs on efficiency grounds. You know, if scientists choose their problems to solve, they are better equipped to solve them successfully. But you can acknowledge that usefulness to society is a legitimate demand on science, but defend that scientists should be left free to follow their curiosity anyway. And this is Bush's well-known utilitarian defense of scientific freedom as regards the setting of research agenda. So just to recall that this is a well-known quotation from Science, the report Science, the Endless Frontier in 1945. So utilitarian view of science, scientific progress is one essential key to our security as a nation, to our better health, to more jobs, to a higher standard of living, and to our cultural progress. So basically useful for everything. But scientific progress on the broad front results from the free interplay of free intellects working on subjects of their own, of their choice, in the manner dictated by the curiosity for exploration of the unknown. Freedom of inquiry must be preserved under any plan for government support of science. And this gives you this classical, well-known cascade model of the relationship between science and science policymakers. And policies of research oversight and funding should just limit themselves to inject money in scientific communities and let them do what they want. And society will then receive in return all kinds of benefits, technological innovation to fuel economic growth, expertise, knowledge, improving living conditions, and so on. But the fact is that this cascade model is clearly, for several reasons, is clearly not tenable anymore. And this is quite vividly acknowledged, for instance, in this editorial from Nature I mentioned just before. Because after pointing out the gap between the outputs of research and the needs of society, the ed explained that just telling the same old stories won't cut it. The most seductive of these stories, and certainly the one that scientists like to tell themselves and each other, is the simple narrative that investment in research feeds innovation and promotes economic growth. So what I want to propose now is a lecture of the decline of this cascade model in terms of evolutions of expectations towards science. And I like this statement by Neil Lane, a former director of the NSF. It is not that science did not deliver in so many ways over so many years, but rather that different times require different types of accountability. And my main claim here is that what we have now in the recent period is a shift toward more pressing and more targeted expectations. So let me explain briefly this claim. This shift toward pressing and targeted expectations first can be seen as the other side of the coin of the very success of science. And innovation in our knowledge society, because as we all know, science is considered as a key element of many aspects of the development of our societies. So if this is the case, then it shouldn't come as a surprise that public science funders and other actors, other components of the society, do not expect from science just more knowledge and more innovation, more knowledge and more innovation tout court, as Bush did, but more knowledge and more innovation on a specific topic, in specific domains which are identified, are priority domains where we need more knowledge and technological innovation, and sometimes urgently so. And so this shift from toward more pressing and more targeted expectation, that can be reformulated in terms of a shift away from an offer mode to towards a demand mode of production of knowledge. Just to put things very simply, in the offer mode, you have this idea that scientific inquiries should be or are or should be mainly oriented by endogenous problems. That means problems defined by scientists themselves in light of what they think is interesting in the dynamics of their field. And so scientific inquiry is mainly oriented by such endogenous problems. We produce new knowledge that in turn may lead to very useful developments. And the laser is clearly the paradigmatic success story of this view of science as filling a reservoir of knowledge by following, by scientists following their curiosity. So they fill a reservoir of knowledge, and then later on you may have wonderful things such as the laser, and very useful things such as the laser. But in the case of the laser, you find how to use it afterwards. It's not like you have a need and then you come up with the laser to respond to this need, to this identified need. It's the other way around. You find the way to use the laser after you have the laser. And so the shift toward a demand mode, in that case, scientific inquiries are mainly oriented by exogenous problems, problems coming from, not from the internal dynamic of a scientific field, but from society. And so some particular problems and needs of society are identified, and addressing them will then constrain and direct research programs towards specific topics. And of course, in the background of that, you have all these science and technology studies contribution describing changes affecting modes of research funding and setting of research agenda, and the most discussed one, I think, being the mode 1 versus the mode 2 production of knowledge. Okay, so but the key normative philosophical question is now the following: is this shift toward more targeted expectations legitimate and desirable, or should it be resisted? And if so, on which grounds? So that's going to be my central normative philosophical question for later on. And so I'm going first to discuss who is to decide what the very aims and value of science are in our societies. And that's what I call my sticking point 1. And so should we, for instance, and this is going to be my focus, should we still value unpredictability as it is usually the case? And the second moment is going to be the epistemological issues, as I said, as I announced already, epistemological issues of epistemic fecundity, but more on that later. So let's start with the first question. Okay, so who is to decide what the very aims and value of science are? So as we all know, philosophers of science are traditionally very good at discussing what the epistemic goals of science are, laws of nature, finding, produce objective explanation, unifications, or sometimes more specific things like making use of causal patterns by using idealizations and so on. Okay. But that is not the question here. The question here is there are more like two levels of question. When you ask who is to decide what the very aims and value of science are, a level 1 question is very broad and very fundamental, and is all as science, and it dates back to Aristotle and all that. So should these epistemic goals be ends in themselves? So it corresponds to what is usually called disinterested views of the aims of science, or decontextualized view of the aims of science, or should these epistemic goals just be instrumental to practical ends, and those are basically utilitarian views of the aim of science. So this is an old difference of views of the aim of science, nothing new here. And then you have, if you go for utilitarian views, then you have a level two, another level of question, which is, well, then what should these practical ends be? And then depending on your political views, you may put more weight on economic growth or more weight on strategic independence or the common good, whatever that means exactly. Like, okay, let's reduce inequality, let's reduce CO2 rather than adapt to climate change. Anyway, whatever are your preference, your political preference among these practical ends, my point is simply that in both cases, the answer should be political, both for level one question and level two question. It's clearly, I think it's clearly unproblematic for level two question. But then, of course, you have to say more about how society decides what are these, what should these practical ends be? Is it the government? Is it the citizen directly and all that? Okay, so there are all these interesting debates, philosophical debates about how to choose these practical ends and who should do it. But that's another issue. My point, which is not a deep point, is just that that should also be the same for the level one question. And because after all, in a democratic society where research is at least in part funded by public money and plays a central role in so many aspects of life, it is not up to scientists or for that matter to philosophers of science to decide what the aims and value of science should be. In other words, we should drop any essentialist view of the aims and value of science at the level one question and go for a thoroughly political, hence evolving one. And because you, and that's important for the point I want to make about unpredictability, because you have to acknowledge that this view of the very value of science can be evolving depending on the role that on the evolution of the expectation towards science and the evolution of what you expect from science, and that's going to be my main point here. That directly impacts the value you put on unpredictability. But before explaining that, let me just distinguish at this stage of the talk. Let me just distinguish between two kinds of unpredictability. The first kind of unpredictability is unpredictability as unforeseen practical applications. So this is just again the laser type unpredictability. You are free to fill a reservoir of knowledge, and then something unplanned may come out of it. And the laser was evidently not a foreseen application of the development of quantum mechanics 40 years before, obviously. The second type of unpredictability, and that's going for the one I will draw on in the third part of my talk, is unpredictability as unforeseen opening of new lines of research and discoveries when unexpected result or observation occur in the course of an inquiry. And that typically, the history of science is full of this kind of happy, unexpected result, if I may say. And for instance, the Fleming's discovery of antibiotics, penicillin, or also in cosmology, the discovery of the cosmic microwave background by Panzias and Wilson, which was really an unexpected result of another a research program aiming at completely something else. Okay, so now I'm going to talk about the first kind of unpredictability. And my point is going to be the following. Laser type, so unpredictable outputs, so unpredictable in the first sense, may remain valuable when long-term contribution to economic growth and competitiveness remains a central expectation towards science. Because, you know, it's this usual discourse about what you want unpredictable breakthrough innovation, opening new markets and all that, as the laser did, or many other things, okay? But a properly functioning democracy may hopefully broaden and diversify its expectations towards science and go for, if needed at a certain time, and we may think that in 2020 we need that, which might not have been the case 50 years ago, but if needed at a certain time, you go for more targeted and short-term expectations to resolve health problems, environmental related issues, strategic, whatever. And that makes laser type unpredictability a less valuable feature of science. And as John Bernal said, although it is true that we do not know what we may find, we must in the first place know where to look. So my intermediate conclusion concerning this part of the talk is the following. Should we still value the prospect of enforcing application when facing pressing, well-identified specific issues to which science could contribute to solve? And I would suggest a negative answer. Once the shift toward more targeting, pressing expectations is deemed legitimate, and we've seen that that's a political issue. It's not the essence of science to say, to go for that or not. So it's a political issue. So then research oversight policies should favor research programs mainly oriented by exogenous problems and aiming at responding to identifying needs. In other words, it seems that today, nowadays, we know what we need. There are many things we know we need, like better energy storage devices, for instance. And so we should go for research program aiming at that, rather than saying that we need research program because 40 years down the line, we will be happy to have the next laser. Well, that might be the case in 1950, but maybe it's not what we should expect from science nowadays. So the first way out of the tension between unpredictability and social responsibility is to downplay, to drop the value of unpredictability as enforcing application. Okay, so let me check the time. Okay, so let's move on now to my third part of the talk. My third part of the talk, the sticking point 2. And here's the challenge for the science policymakers as regard the setting of research agenda. You can say, okay, it's to navigate between the political characters of societal relevance and the epistemological sila of loss of epistemic fecundity. Because so what I'm going to discuss now is this prima facie tension between the need for scientific autonomy in the choice of research topic to foster epistemic fecundity, or so the story goes, and the need for orienting science to increase its relevance and utility for society. And so how can philosophers of science help? They can help by showing that exogenous guiding of scientific research does not necessarily hamper its epistemic fecundity, contra the popular unpredictability argument which I'm going to discuss now. And actually, it might be the opposite, as I will try to show now. Okay, so about the, so let me first recall what the unpredictability argument is. And this argument fuels resistance to any planning of science towards society needs. And again, this very well-known statement by Polanyi, resisting any research planning. Any attempt it's in a lyric form, like any attempt at guiding research towards a purpose other than its own is an attempt to deflect it from the advancement of science. You can kill or mutilate the advance of science, but you cannot shape it. Okay, that was in 62, but this is exactly the same kind of position in public debates about research policy today. And just to pick up one example of public statement among many, this is this statement by the administrator of the Collège de France, which is in France a scientific institution really favoring blue sky research and disinterested research. And Alain Prochance is not very nuanced. He said, okay, I would call rampant Lysenkoism the permanent incentive through research programs on societal questions to mobilize researchers on big industrial or humanitarian issues. Many examples clearly demonstrate that the most promising recent discoveries in medicine have been made in a spirit of pure cognitive curiosity. See, for instance, the discovery of the RNA interference phenomenon from experiments on the color of petunias. And I will come back on this example in a moment. So just to sum up the unpredictability argument. So first, according to this argument, major discoveries, or so the story goes, are often unplanned ones, which then open whole new domains of inquiry. And the orientation of the inquiry by external considerations, like exogenous problems, is deemed epistemically counterproductive and vain. One should not attempt to predict the unpredictable. And by external consideration, I just mean things, utility in light of the needs and concerns, both practical and epistemics of society. It's by contrast with questions internal to the dynamics of a curiosity-driven scientific inquiry. So the central epistemological issue is going to be the following. Is it really the case that a research whose agenda is set according to external consideration is less hospitable to the flourishing of the unexpected than the research whose agenda is freely set internally by scientists following their curiosity? And in a joint work with one of my former PhD students, Baptiste Bédessem, who played a very important role in this paper, we gave a negative answer to this question in a paper published last year. And so let me just explain why we give a negative answer to this central epistemological issue, this question. Okay, so now I'm going to talk about the second kind of unpredictability, like unforeseen opening of new lines of research and discoveries when unexpected results or observations occur in the course of an inquiry. Okay, so in this paper, to answer the question, in this paper, we propose 3 epistemological features which influence the occurrence of the unexpected. And just a terminological precision, we call unexpected a result or an observation, outcome of an experiment that is not only surprising at first sight, but that cannot be accounted for within the theoretical or epistemic framework in which the empirical inquiry has been considered and conducted. And so these 3 epistemological features we identified as influencing the occurrence of the unexpected can be considered as criteria for favoring or not the occurrence of the unexpected. So the first one is what we called leeway. The first one is leeway for the manifestation of uncontrolled factors. The second one is diversity of object under study and of experimental approaches. And the third one is how hegemonic and plastic is the theoretical background. And before explaining each of these criterion, let me just say that the general thrust of our proposition is simply that the following. The occurrence of an unexpected result is linked to our intervention in the world being partially uncontrolled. So let's start with the first epistemological feature, the first criteria. So leeway for the manifestation of uncontrolled factors. So our claim is that is simply that manifestation of uncontrolled factors, which is characteristic of many historical cases of unexpected discoveries, such as Fleming's discovery of the penicillin, can be directly linked to the degree of isolation of the object under study. And why this is rather simple, and Hacking reminded us a few years ago that many objects of contemporary experimental sciences are created in the laboratory rather than existing as such in the real world. But the point is it's like he gave the example of the Hall's effect, created in 1879. If anywhere in nature there were this arrangement with no intervening causes, and that's the part which interests me, then the Hall effect would occur. So starting from that, you can easily develop this idea, or draw on this insight to notice that isolation, purification, and control of intervening causes in an experimental protocol tend to limit the number of causal pathways which can influence the response to experimental investigation of a given object under study. And then unknown causal pathways existing in the real world are thus inoperative or less operative in highly controlled laboratory conditions, thereby limiting the occurrence of unexpected results. And inversely, a low degree of isolation and control favors the manifestation of unknown causal pathways and hence the occurrence of unexpected results. So that's for our first criteria. So leeway, for the more leeway you have for the less control of the experimental setup, the more leeway you have for the manifestation of uncontrolled factor, the more hospitable your scientific inquiry will be to the unexpected. Criterion two is straightforward. It's more or less a straightforward consequence from the previous claim. So diversity of object under study and of experimental approaches. Multiplying the types of objects and the types of experimental approaches used to study them increases the probability that some uncontrolled factors intervene and that some unknown causal pathways become manifest. So again, it's a straightforward consequence of the previous consideration. So the more diversity of object under study and of experimental approaches you have, the more likely the occurrence of the unexpected is. Okay, now third epistemological feature, third criteria, what we call hegemony and plasticity. So it's about the degree of hegemony and plasticity of the theoretical background. So the claim is the following: a well-established theoretical framework may hinder the occurrence of the unexpected when it is in a hegemonic monopolistic position, that is when it constitutes the dominant theoretical framework of inquiry in a given field. Why? Again, we can start from Hacking's insights about laboratory sciences, and Hacking's explained that as the laboratory science matures, it develops a body of types of theory and types of apparatus and types of analysis that are mutually adjusted to each other. And in that case, a well-established, but drawing on this insight, extrapolating this insight, so to speak, you can conclude that a well-established theoretical framework determines the type of question that can be investigated experimentally, guides the design of apparatus, and defines the type of data produced. Thus, by constraining the type of experimental procedures developed and the type of data generated, a theoretical framework which is in a hegemonic, monopolistic position in a given field tends to, and that's the main point, tends to homogenize the experiments conducted to investigate the phenomena studied in the field. So that gets us to our third criterion. Theoretical hegemony reduces the opportunities for the occurrence of unforeseen results, since it reduces the diversity of experimental approaches, hence the possible sources of emergence of unexpected results. And that was our criteria 2. And moreover, in addition to this first claim, moreover, concerning this third criteria, when you are faced with a surprising result, when faced with a surprising result, researchers will be reluctant to let go of the framework, of a well-established framework, in order to search for an alternative, and for good epistemological reasons. There is obviously a high epistemic cost to abandoning a well-established, successful theoretical framework, and these are well-known insights from Kuhn, Lakatos, and all that. So the concluding point here is that it is more likely, when you have a well-established background theoretical framework, when you work within a well-established background theoretical framework, it is more likely that the surprising result will be integrated within the existing framework rather than opening a new line of inquiry. And I just want to give one example here, which comes from the field of the etiology of cancer. First developed in the 70s, the classical theory of cancer, the somatic mutations theory, the SMT theory, rapidly became the dominant theoretical research framework on carcinogenesis, with the ambition of accounting for all types of cancer, despite having been challenged for 15 years or so by a new theoretical approach, the Tufte approach. And this hegemony of SMT led to a high degrees of homogenization in experimental inquiry in that field. And in the context of molecular biology, the experimental procedures adopted were all dedicated to a very standardized search for genetic mutation. And also, many, just to complete this example, many, if not all, surprising observations were made compatible with SMT by using ad hoc hypotheses. And an observation which was unexpected, like the large-scale disorganization of the genome, that could have led to a radical criticism of the expectative framework used in cancerology, was simply because this framework was in kind of monopolistic situation. This unexpected observation was simply reintegrated within the prevalent model. Okay, so in light of these three criteria, how does an external setting of the research agenda, so when research is expected to address exogenous problem, so how does this external setting impact the occurrence of the unexpected? Our first claim is that addressing exogenous problems may increase diversity of object under study and methodological approaches. So according to our criteria 2, that will favor the occurrence of the unexpected. And why? It's because since exogenous problem by definition incorporate interest and needs external, or at least partially external to scientific communities, they may not, and they often not coincide with research questions that would have emerged in light of the curiosity-driven internal dynamics of the field. And so the pressure of exogenous problems can lead to a proliferation of local models and associated specific experimental protocols in the absence of a general explanatory framework, hence favoring the occurrence of the unexpected, and that's our criteria too. And I will give just two examples here. If you consider, for instance, at the beginning of the 19th century, the study of fermentation processes. Fermentation processes were at the core of many practical activities, beer brewing, wine and vinegar making, baking, and so on. And they led to a large number of experimental techniques. And so there was a very, there has been a very rich moment with many hypotheses, unexpected results, because there was a proliferation of experimental protocols, diverse experimental protocol and model. And so in that case, to get it short, in that case, the pressure of exogenous problems such as improved fermentation processes lead to a proliferation of local model experimental protocols, and that favored the occurrence of unexpected results. And another example is, if I have time, yeah, quickly. Another example is in the case in oncology. There are many examples. We give many examples in the paper I mentioned, but just to give another example, in oncology, look at the development of radiotherapy in the first half of the 20th century. So the aim was to intervene on cancer in order to cure it. And despite at the time the absence of any general model of describing the mechanism of carcinogenesis. And so in a way similar to the previous example, there were no standardized protocols. There were many experimental protocols, local models that were tested, and many unexpected phenomena occurred, results occurred. And so again, to cut it short, this is another example amongst many of the pressure of exogenous problems here to cure cancer, the pressure of exogenous problem leading to proliferation of experimental protocols and local models, and hence favoring the occurrence of the unexpected according to our second criteria. Okay, second claim, to addressing exogenous problems is often linked with low degrees of control and isolation of experimental settings. Why? New research questions are introduced, which are not chosen primarily because of their tractability with respect to well-established theoretical backgrounds or well-controlled experimental practices. So this is the case when you address exogenous problem. And Martin Carrier, for instance, wrote about that, very, very interesting things. So a research program addressing exogenous problems typically aims at directly intervening on a process or phenomenon, while often disposing of only a partial knowledge of the causal chains involved, and without being able to isolate it from various causal influences exerted by the rest of the physical world. And I will give just here one example of such a contextualized causal relation, and that's the terminology by Martin Carrier. And so such contextualized causal relation go hand in hand with a relatively low degree of control displayed by the experimental protocols. And the example is precisely the example Alain Prochian used to defend scientific freedom and reject accountability and social relevance. This is a discovery by Fire and Melo of the RNA interference phenomenon. We should remember that the initial motivation for this research program was a practical motivation. It was really an exogenous problem. It was enhancing the color of petunias. And on the way, there was a very unexpected result, the discovery of the co-suppression phenomenon due to an unknown mechanism, a non-causal mechanism at the time. So without getting into the details of this case, this is a nice example of use-inspired research leading to a breakthrough in fundamental knowledge, in that case, in our understanding of gene regulation. And you have all the details of this story in another paper written by Baptiste Bédessem a couple of years ago. Okay, so one last consideration in favor of the hospitality of exogenous research programs, research program addressing exogenous problems, donc hospitality to the unexpected. Scientists working within well-established theoretical backgrounds may tend to attenuate the surprising and problematic dimension of a result by trying to incorporate it within the framework. But the pressure of an exogenous, so we saw that, we discussed that previously, but the pressure of an exogenous problem may pull actually in the opposite direction. In the course of a scientific inquiry addressing some pressing problem, the occurrence of an unexpected observation tends to be considered as a sign that the strategy proposed to solve it has failed. So the surprising observation is thus considered as a real issue to deal with. Its unexpectedness is thus accentuated rather than erased by integration within an existing framework. So my second, not intermediate conclusion, but my second conclusion concerning this third and last part of my talk. It turns out, if we are correct, it turns out that the importation in the scientific inquiry or in setting the research agenda, the importation of exogenous problems may actually favor the occurrence of the unexpected by first justifying the objects under study and the local models and experimental protocols used. That was our second criteria. By leading to intervene in poorly known and controlled object and causal mechanisms. That was our first criteria. And by limiting the tendency to integrate surprising results within an existing dominant epistemic framework. And that was in light of our third criteria. But when you are interested in the general conditions favoring the full flourishing of the unexpected, this is only half of the story. The other half of the story is that, well, you have to, once you have favored the occurrence of the unexpected, then you have to make sure that you are able to follow up on these surprising results. So the other half of the story are the optimization of follow-up once surprising results calling for more investigation have been found. And so it's really important, I think, to distinguish between issues of occurrence of the unexpected, and that's what I talked about, I've just talked about, and issues of what I can call, but it's not, I'm not very happy about that, the management of the unexpected. And in the second half of the story, the management of the unexpected, the issue is not a pure epistemological problem. It's a question of science policy. So what are the organizational features of science that will allow and even encourage fruitful follow-ups? And not surprisingly, you can easily make a case that what you need, it's not so much scientific freedom to choose your topic of research, but what you need is flexibility within the course of a given scientific inquiry. You have to be able to change direction of research and to be able to follow up on unexpected results. So that's what research policy should facilitate, this flexibility within research programs. So to sum up this last part of my talk, an appeal to the unpredictable nature of scientific developments does not constitute a sound argumentative strategy to resist the orientation of research by targeted exogenous problems on the grounds that it will hamper its epistemic fecundity. That's what hopefully we established with Baptiste in our paper. And so to foster the full flourishing of the unexpected, what matters is not scientific freedom, freedom to work on this problem on your own choice, but freedom to follow up unexpected results, which is quite different as regards science policies. So it's very important, I think, to distinguish here between two kinds of research planning and research oversight. Research planning as what you may call, but finalization of research. That means research planning, you set the research agenda in order for science to be able to respond to the needs and demands of society. So research planning as finalization of research in that sense is politically desirable today and epistemologically acceptable, as hopefully I've just shown. But that shouldn't be confused, as it is often confused in the public debates about research policy. That shouldn't be confused with the research planning as advanced specification of the intermediate steps and achievements of the inquiry. And that, this second kind of research planning is epistemology not desirable. And so it's important to distinguish between the two, because you can make a case for the first kind of research planning without having to make a case for the second kind. But of course you can say that's all very nice, but today usually you have the two kinds of planning together, but that's contingent, if I may say. It's not, it doesn't have to be that way. Okay. And so okay, so just and that's my last slide. Just a few remarks on planning issues. Okay, it might be the case that given the role of science in our society today, given the evolution of expectations, legitimate expectation towards science, we might have to drop, to stop valuing unpredictability in the sense of enforcing application. But of course, this is easy to say, but that means a big cultural change of the image of science, but not only of the image of science, but also of the motivation of people when they enter research careers, and that's not so easy to change these motivations. And the second pending issues is about this flexibility. So more flexibility and not more scientific freedom, more flexibility, which is needed to foster the full flourishing of the unexpected. It also, by the way, runs counter to the previous difficulties, as you need a cultural change, you need to make the motivation of people entering research careers evolve and all that. But I think it also, I'm not sure it is compatible. I don't know if it's compatible with the need to solve urgent problems. So you might have like a time issue, but I leave that for further discussion. Thank you.
All right, thank you very much. As I always say, one of the downsides of webinar is that we can't really clap because it's only you and Alex. All right, so let me remind you how we're going to be proceeding. If you have a question, please write down your name in the Q&A box. You can click on the Q&A button at the bottom of your screen, and I will promote you to the status of panelist. And then you can ask a question to Stephanie. And it takes a few seconds for me to do that, so bear with me, and I will already start moving you to panelists. All right, David, the floor is yours.
I don't know if I'm visible, but
we can see you.
Okay, great. Yes, thank you. I wanted to pick up or ask a bit more about something you'd said about halfway through the talk. You were comparing laser development with, I think your example was a need for more energy storage, and as a particular example of the fact that if we have more sort of specific and defined and societally or politically motivated research goals, then it becomes less of a problem that we don't get the sort of blue sky surprises. And I'm interested in how in this framework we want to think about the extent to which very often historically sort of blue skies follow endogenous questions work has been completely transformative for the environment of solving these kind of practical problems some decades down the chain in ways that couldn't have been predicted. So I think for energy storage, I mean, I don't know a great deal about the details of the science here, but lasers are absolutely ubiquitous as a technological application in solid state physics. Just a quick Google search finds plenty of cases of, here's such and such idea of how we need to use laser technology in the improvement of lithium-ion battery design, things of this kind. So that's a case where we needed those ideas that were developed outside the context of the pressing problems of the 1970s in order to address the pressing problems of 2020. But in a sense, the laser is a very minor key example here. I mean, if you ask what were the pressing problems that would be identified by the politics of 1900 that would have led people to study the structure of the atom and travel along the path to quantum mechanics, it's difficult to see those. And yet without the framework of quantum mechanics, then our resources to address the pressing problems of today are transformed essentially out of recognition. And I think you can say the same for thermodynamics or perhaps less so for electrodynamics in the 19th century. I know the science less well, but I suspect something similar could be said about the discovery of DNA and the beginning of molecular genetics. So I'm just concerned that the longer term consequences of this kind of agenda is that one might in the short term do better at solving those practical problems, but in the longer term it becomes self-defeating because you don't have the continued development of the transformative theoretical structure that lets you solve the practical problems later.
Yeah, I think you point to the idea that, for instance, if you go back to the Manhattan Project and the very quick development of the atomic bomb, Vannevar Bush said that, okay, we were so efficient to do that. It's because for the previous decades, physicists fill up the reservoir of knowledge with fundamental knowledge. So we had this reservoir of knowledge, okay? And so that's what, so the question is, if we stop filling this reservoir of knowledge, if scientists stop filling this reservoir of knowledge following that curiosity, then, as you said, down the road, long term, we might be without resources to solve our practical short-term problems. But then you can. This is not when you try to solve short-term problems. This is not like you stop filling the reservoir of knowledge. You know, Thorsten Willott, for instance, and other philosophers showed that applied research programs do produce down the way many important fundamental insights. So it's another way to fill up this reservoir of knowledge. It's not by following freely your curiosity, but it's just to, if you are free to follow interesting, unexpected results in the course of finalized inquiry, it's another way to fill this reservoir of knowledge. And you win on the two tableaux. You win because you are actually filling the reservoir of knowledge, and also by doing so, you're trying to resolve a short-term issue. So I'm not sure the tension is real if you acknowledge that solving practical problems require fundamental insights and just not use the current theories.
Sure, but my concern, and perhaps this is specific to physics, is that this is a field where there's a very high depth of theoretical data. It's not just that to make the Manhattan Project possible, there had to be lots of specific quantifiable increases in the reservoir of knowledge. It's that the whole framework of ideas that made it possible was developed in utterly different contexts, and by its nature was extremely remote from things that you could possibly see could have had an application prior to understanding it faster. It's really, I mean, maybe it's just my lack of imagination, but it's really hard to see how you could bootstrap your way to the abstract formulation of contemporary quantum mechanics through concrete problem by concrete problem. And if you want a really sharp one, although it was much less important, think about general relativity.
Yeah, but we have quantum mechanics for more than a century now, so it's here, and we can do many things with it. So the question is, okay, so maybe there are many pressing things we need to do now, because, and as I said, it's the other side of the coin of the success of science, because, you know, when you ask money for science, you say, okay, it's useful for everything, you know. But so the other side of the coin of this success is to say, if it's useful for so many things, then let's be useful for the things we identify, which are already identified as in need of scientific contribution. And let's start with that, because if you agree that there are like pressing issues nowadays, let's start with these pressing issues, and then maybe in 50 years we will go back to a more offer mode of production of knowledge. But I think there are political reasons to say, okay, for the moment, we might stick to the demand mode of production of knowledge. Because
but do you think if that had been the attitude from 1850 to 1900, we'd be better placed now?
Well, because that gets back to my point about the evolution of our expectations towards science. If you read all this, well, if you look at the number of development of society which is directly dependent on scientific advance and innovation, much more dimensions of our societies are dependent on scientific and innovation now than in 1930. And I think that you would agree with that. And so because there is this central role in so many aspects so our expectations, as I said, are now more targeted and more specific and more pressing, and it's okay, it's legitimate. And again, it's the other side of the coin of the very success of science in our society. So you can't have it both ways. You can't have the success of science in so many aspects of science, in so many aspects of society, and at the same time say, let's be again still free to research on any topic. So you can't have it both ways. And I think today.
Let me not push further. I've taken more than my fair share of time. Thank you.
Thanks, David. Stephanie, could you just turn off the shared screen so that people actually can see the speakers full in the full screen, if that's possible? Yeah. Thank you very much. Mike, the floor is yours.
Hi. I enjoyed this talk. I had a question that I think is sympathetic to what David was just pushing on, but I'm thinking of it in a slightly different way. So keeping the same two sides of the coin. So on one side, there's a sort of utopian perspective. On the other side, there's a worry that ignoring the utopian side is myopic, and then the conversation proceeds from the other direction of, well, the utopian is too far detached and is not concerned with issues of societal importance, and so far from being accused of being myopic, it's in fact the most important things are the things happening right now. So with that being the backdrop, I'm actually very worried about the ways in which the exigent structures on the political end or on the economic end are shaping science just in virtue of these being the most pressing concerns. And so then I would think that we would want science policy crafted in such ways to counteract that. And so that would push me towards this utopian angle of saying, okay, so the role for science policy is to allow for the sort of freedom that would eventually give rise to the transformative change, because pressing problems are so pressing that if we don't create that room, science will inevitably only wind up being concerned with the most immediate urgent issues. So I was hoping you could save me from my worrying about that angle. I hope.
Yeah, but I would tend to say, to answer, okay, why is that bad that you might think, given the nature of the problems we are facing, if you agree that we are facing problems like the climate change and all that, you know, and that you agree that those are pressing problems, and then why is that bad to, for a certain amount of time, to do more or less what has been done? I mean, the comparison is far-fetched for sure, but you could agree that we needed to strongly finalize science to win the war. Imagine, okay? But then you can say, okay, let's extrapolate that and say, okay, now we have really pressing issues. So but let's accept for a moment to strongly finalize science to solve these problems, and then maybe later we can go on with a more utopian, as you said, Ruphy. But what on which grounds you would say, okay, let's not when setting the research agenda, let's not try to resolve these pressing issues if we think that science may contribute and if we think that they are pressing enough. I don't see on which grounds you could resist that. I don't think there are, the epistemological grounds, I try to show that it's not a very strong one, because finalized science can be very creative and very epistemically productive as well. And so it will be on the political side or the cultural side, but then you have to make a case for that, and I don't see any strong political or cultural case for accepting that science minds its own business, whereas it could be more useful to society. It gets back to this ebb in nature, how to reduce this gap between what science delivers and what people expect from science, how to reduce this gap. But of course, you can say we don't need to reduce it. That's fine, but then you have to provide a political argument for that, because science costs money and impacts life and blah, blah, blah. So you have to give a political, and it can't be just, well, that's the aim of science, to find out about the world. I mean, that was my point. It's this, what is the aim, the fundamental aim of science? I don't think we should have an essentialist view about that. I think it's given the role of science in society, it's also something, a political issue, to the extent that we might change our view of what is the fundamental aim of science at a certain time.
So maybe I was a bit confused on some of the rhetoric then. I was thinking, or I was taking your emphasis on science as it has come about in its present era to be an invitation to be very worried that pressing issues already dominate our sphere of what is possible for the aims of science. So maybe I'm in different circles or something, but I would think where we've ended up is that we conceive of science in a rather limited way toward only those pressing problems as we presently conceive of them. And so in light of that backdrop is why I would think there would be room for pushback given the same rhetorical setup to say we want science policy to counteract that tendency. But
why is it a limited view of science to think that science should aim at solving pressing problems? I think the key issue is is to define what are the real pressing problems. And then that goes to the whole issue of who decide, who choose, why is it always economic short-term goals. But so you can make a case for broadening, and I completely agree with that. You can make a case, as so many philosophers, for broadening the practical ends of science, but that's another issue. Imagine we live in a properly functioning democracy, then the practical ends of science will be much more diverse than what they are now. You can, okay? And that's, yeah, but that's yeah, of course. I'm not defending the current state of the current weight put on a certain specific pressing issues, like basically economical ones. Certainly not, but that doesn't change the fact that defining the aim of science as answering pressing issues, not reduced to economical ones, is defendable.
That was very helpful. Thank you.
All right, Kelly, the floor is yours.
Hi, Stephanie, that was fantastic. Thank you very much for all of this. And it's a great, like, fantastical exercise now to imagine that we do in fact live in a functioning democracy. So we can in our minds. Yeah, it's great. So I think it's really interesting that what you seem to be suggesting, kind of dovetailing on Mike's questions there, is that if we look at recent developments in the history of science from the perspective of science policy, then what we see is that this view promulgated by Polanyi and others, and even Vannevar Bush to a certain extent, has really been the kind of utopian ideal that they've proposed we be striving for, in light of the fact that the actual development of scientific research infrastructures has been one of very much like use-inspired research. And I think, you know, my background on this is very US specific, but I think it's really striking that the bulk of federal investment in US scientific research and development goes towards much more use-inspired types of research. That this ideal of basic research has functioned as a kind of organizing political ideal for the most part, and has not rather been like an accurate description of what for the most part is going on under the guise of scientific activity. So, so given that, I really just wanted to suggest like what you might think of perhaps shifting the emphasis of your argument a little bit. So early on when you were in your talk, you mentioned like accountability came up as a kind of like minor player in the cast of actors in your argument. And, you know, given where your argument ends up, I wonder if actually that should be like a main role, because Polanyi is just wrong, right? And not only is he wrong, it also seems like it's a kind of red herring to talk about scientific freedom in this sense, because like, who does pure curiosity-driven research? Where does that happen? Like, independently wealthy people can do pure curiosity-driven research. I mean, it just flies in the face of the phenomenology of the scientific enterprise. In that sense, like, everyone who's a practicing scientist has to deal with these like different negotiations about what grant opportunities are available and what the agenda of publishers are, and, you know, the dreaded reviewer number 2, right? Like, everyone has to deal with those sorts of negotiations. And so it seems like it's a kind of it's simplistic and inaccurate to think that we can only have either pure curiosity driven research, or we're like doomed to central planning and Lysenkoism, right? It's surprising how much that kind of like rambling about Soviet era central planning comes up still. So yeah, it's just a suggestion. What do you think of the idea that, you know, accountability is actually the central player here, and these discussions of scientific freedom and this ideal as a consequence of like the unpredictability of research is actually a sort of red herring?
Yeah, well, I agree with the fact that this the very idea of blue sky research remains just an idea and not an actual way of doing research. Well, with some exception, maybe in France it's a bit different, but anyway. But I think that the normative issue is really, is not to be for or against use-inspired research. Is to think about what would be like a well-ordered use-inspired research, if you take the teacher's expression. And I agree with you that at the moment, I think in many countries, the use-inspired research is not well-ordered, in the sense that the priorities of research are a limited subset of the priority you would like to be addressed by science. And with that, I completely agree, but that's precisely my point. I mean, we should go for a well-ordered, use-inspired research. And I think there are good political and epistemological reasons to go for that, rather than defending blue sky research. So I really think that for political and epistemological reasons, use-inspired research is fine, is what you need if you want science to be socially responsible. And but what is very important is that the way you organize and oversight science is not to reduce its epistemic creativity and fecundity, but that was what I tried to establish in this talk. I mean, if you encourage flexibility and all that, that is perfectly compatible with use-inspired research, because you can have no flexibility in blue sky research program. Ask a cosmologist today, he will complain, and rightly so. He will complain that he has to specify in advance what he's going to find in 12 months and in 20 months. That is not linked to the fact that it's blue sky research or use-inspired research. This constant demand of advanced planning, specification of steps and all that should be resisted. But it's another issue than saying we would like more blue sky research and less use-inspired research, because I think at the moment we don't have so strong arguments to defend blue sky research. And the epistemological one, the unpredictability argument, is not the more convincing. We have to, at least people defending blue sky research, they have to come up with a better argument than the unpredictability argument, I think.
Thank you. Nick, the floor is yours.
All right, do you hear me?
Yeah.
Yes, good. All right, so that was a very interesting talk. And I meant to ask a question that's very practical in the sense of, imagine someone sitting on a committee adjudicating grant proposals, and let's say your proposal has been taken into account by the granting agency, so we want to encourage diversity. Especially, you know, I was thinking about it in relation to your second criterion about the diversity of objects of studies and local models and experimental protocols leading to unexpected occurrences. So anyway, with respect to that, imagine two people on that committee are arguing with each other saying, those two projects are really doing the same thing. We should just fund one of them, you know, to be able to fund something else as well. And say the second person is saying, no, they're not, no, they are doing different research. What exactly counts as different? Do you have, I know it's tricky and, you know, it comes down to details, but do you have, say, guiding principles?
So maybe it just means like different experimental protocols, different, you're going to look at, I'm going to say very general things, but you will look at different aspects of the same phenomenon. But the example I gave in the etiology of cancer is a good example for that. When you had this dominant SMT theory, basically for decades, you had only one kind of experimental protocols because you have these dominating backgrounds. So not so many unexpected results are expected, if I may say. And so yeah, it's more like differences in kind of experimental protocols, in the way you're going to control the phenomena you're going to study, because the less you control, the more likely is the occurrence of unknown causal pathways and all that. So I think you could specify, which I haven't done in this talk, you could specify the kind of diversity, the kind of differences you need to favor the occurrence of the unexpected. Yeah, I have to say more about that. Yeah.
Yeah,
I said a bit more about that in the paper.
as a person who had the misfortune of sitting on one of those committees, I think that would be very helpful to say more there. Thank you.
Thank you.
Thanks, Nick. Sandy.
Hi, Stephanie. It's good to see you, and thank you very much for your talk. I guess I had a question about, again, this posing the argument in terms of countering this utopian view, and rather, I think it's convincing that the utopian view, the blue sky view, isn't the only way in which we can get successful scientific results that can be useful. There's two parts of that. One is successful scientific results, and the other is useful ones. And I think if you look at take into account, this is a kind of follow-up from what Kelly was saying, at the kind of funding, both the funding ecosystem now, and the fact that scientists choosing their own paths are choosing it for a variety of reasons, some of which are reflective of this, what the society thinks is important, for better or worse. And it looks like that, at least currently, the major funders are either states or companies, right, for economic goals. And the economic goal structure is one that counters epistemic success, because you don't have to get at what the right answer is to be economically successful. You just have to run faster than your companion from the lion, right? You just have to be better enough. In fact, after you're better enough, you shouldn't invest anymore, because that's throwing money away. And so in a way, the interests of society, if you take that to be the state, are ones in which you have to be, that aren't counter to the epistemic interests of science of getting the right answer, right? In the way that economic motives were. So it seems to me there's an argument about why you need these other sources of directing scientific funding, not just to solve that part of the story, solve the social problems, but to do good science, right? And I was wondering how you thought about that framing of it.
Yeah, well, first, I'm not defending the current funding policies here and there, but I think again, when I think the goal would be like to achieve some well-ordered, in the teachers, and well-ordered use-inspired research, which is clearly, and I agree with you, we are very far from that now, precisely because, as you said, the focus is on economic goals, and you don't need epistemic goals. I mean, not so much fulfilling epistemic goals to do that. And I agree with that, that is not satisfying. But the question is now is what in which direction do you want to go to escape this current situation? Do you want to go to depart from the idea that and science should answer society needs, but not only economic ones, because so you can make the case for the fact that by answering economic ones, it is not answering the whole spectrum of society's needs. So that is problematic, okay? But you don't have to go for, let's go back to blue sky research. I don't know if it's clear. It says it's a way to depart from the current situation is not to go to defend epistemic goals as ends in themselves, but to defend epistemic goals as instrumental to practical ends which are not reduced to economic ends.
Yeah, I think I understand that. I was just suggesting there's a stronger argument that economic ends are inconsistent with the epistemic ends in the way in which using problems that for social benefit are not.
Yeah, I agree with that. Especially, all these issues of commercialization of research, and I can agree with that. But I don't see why it's in tension with, it's a problem for defending a well-ordered, on the normative point of view. Why is that a problem for defending what will be a well-ordered use-inspired research that will actually answer to the various needs of society and not just to serve the interest of some dominant groups of society? So I don't see why it is a problem.
Yeah, it was addressing a different issue. So yeah, it's not a problem. There is what I do. I mean, it's probably not surprising. I agree with is this appeal to diversity and pluralism, and then the question is the well-ordered, right, one that's directed towards increasing that kind of plurality, or is it just increasing focus on a specific set of social problems that we deem to be important now? So again, you know, obviously you want a lot of things to happen to promote good science that serves the interests of the society, right? And so the trick is to try to figure out how being interested, being well-ordered in the sense that you want to solve these problems can or doesn't thwart the pluralism, now not the anything goes utopian picture, but the pluralism of research that you need for the epistemic ends that you want to use for the social ends. So maybe I'm just confused about it, but thank you very much for your talk. Edward, you're muted if you're talking.
Thank you, Sandy. Hans Oettinger, the floor is yours.
Thank you. I'm a bit puzzled. I would like to come back to the Manhattan Project just to better understand. And what was the pressing issue at the time? The pressing issue at the time was stop the Germans, stops the Japanese. I mean, that is what I would have perceived as the pressing issue. And now what should I do? And how would I decide about what to do if I would not have this big reservoir of fundamental knowledge, if not somebody had looked into nuclear fission in the first place, without having special relativity to have an idea where the energy should come from to build that kind of bombs, if that was the trick at all. And so, I mean, this is a typical example where so much fundamental knowledge is required in order to have a plan at all for how to approach the pressing issue. So I think it's so obvious to me that we need what I would call basic research or fundamental research and applied research. And I thought there was a general understanding that the combination of the two things is the ideal way to go. So I don't see why it has to be either or, and only one thing can be good and the other one is bad. That's how it comes over. And I of course, I would like to do something like basic research, but I would hate to do blue sky research. I mean, the word is just as manipulative in order to discriminate the one kind of doing things. And I think we need both, and we should welcome both, and we should continue to fund basic research to keep this big pool alive. And of course, we should also have applied research, and the applications should, if possible, be pressing ones. So that's all fine. But the mix is the national thing, not just going the one or other direction and forcing it that way. What did I get wrong there?
No, but I'm not saying at all that we should stop trying to increase fundamental knowledge about the world. I'm not saying that at all. I'm saying that
And that is blue sky research, or what is that?
Yes, but so
nicer name would be somehow more appealing.
No, so let's be clear. I'm not saying let's not try to increase our fundamental knowledge about the world. I'm really not saying that. I'm saying that you can have pressing issues to solve, and then you can leave enough flexibility and freedom to scientists to find solutions to pressing issues, and on the way, let them free to increase the fundamental knowledge they need to do that.
Yeah, but so World War II would have taken 20 years longer.
It's another articulation of fundamental knowledge and solving practical issues. So what you have in mind is the traditional reservoir of knowledge, so you fill it up, and that's good if it's useful, but you don't know. But there are other dynamics, and if you look at many cases, and again, for instance, Thorsten Willert wrote nice papers about that. That you tried. Some people call that strategic basic research. So you try to improve your fundamental understanding of the world, but not just for the sake of it, because you think that by doing so you will solve a certain issue, and that's fine. So it's not about let's not try to increase our fundamental knowledge anymore. It's a way to articulate the two type of research, and I don't think the best way is to be always in tension and lobbying for more money for basic research and lobbying for more money. I think we should go beyond this traditional tension and all the political lobbying behind that. I'm not sure it's the best way to organize the research at the moment.
Yeah, but if there are pressing issues, I mean, that has something to do also with a pressure of time. I mean, like in case of World War II and climate change and so on. I mean, it's too late to develop the things at that point if you don't push enough for having the reservoir of information. I mean, the nature of pressing issues is that the argument of you develop it once they are formulated seems to be flawed.
No, but if you take the example again, if you take the example of the color of the petunia, you can start with a very practical issue to solve, like maybe not a very interesting one, enhancing the color of a flower, and by doing that, you end up with a fundamental knowledge about genes and all that. So it's not intention. It's not because you're going to solve a practical problem, you are not going to improve fundamental knowledge. Or my point is that research policies should be conceived such as allowing a scientist to do both at the same time and not one or the other. You try to improve something practical, but you leave the scientist the freedom and the flexibility to, on the way, if something unexpected happens, to fill the reservoir of knowledge. But in that cases, you also fill the reservoir of knowledge. And I think it's an open question it's an open question whether this way of filling the reservoir of knowledge on the way to practical ends is less efficient than the traditional way of let's do what I want, or let's follow my curiosity. And I think it's an open issue, and I would like to see an argument making a case for more efficiency of the first mode. I fill the reservoir of knowledge following my curiosity, and the second mode of filling the reservoir of knowledge on the way to solving pressing issue. I don't see any argument for that. I
think the Manhattan Project is a striking argument in favor of dealing with existing knowledge.
Well, but as you know, we haven't changed our basic physical theories for more than 1 century. So in some branches of science, you can say, okay, the reservoir of knowledge is pretty full, and let's make the most of it. And if on the way we realize that we need other type of knowledge, that's fine. But in physics is maybe not the good example to define the traditional the traditional model of filling the reservoir.
All right, I think we are going to stop this exchange here. I'd like to thank you for this very provocative talk, and as you can see, I think it created a really good discussion between you and the attendees. So thank you again for joining us for this ALS lecture. We're sorry you were not able to come to Pittsburgh, but we'll make sure in the future that it does happen in the foreseeable future. Now, some of the fellows and I will see you in 15 minutes.
Okay.
You must have also the link.
Yes, I did,
but
yeah.
thank you again on behalf of the center for this wonderful lecture.
Well, thank you for the invitation and the questions. Thank you.
Bye.
Bye-bye.
See you soon.